I'm delighted to welcome Chris Beeley, Head of Data Science at the Strategy Unit, to tell us about the model that they've developed and continue to develop. I think that's right, Chris. Over to you, Chris.
All right, thanks very much. I will just share my slides. I've had some sound issues instantly, so if I do have any sound issues in the next hour, just shout at me and I will switch my microphone. I don't know.
Sounds okay at the moment.
Has been. Yeah, cool, thanks. Right, yes. So I just want to mention as I will probably talk about more as I go through the thing, this is like, I am presenting these slides, but there's a colossal number of people that have worked on this, and several of them were doing it long before I even got here. So I want to acknowledge their contribution, and I also want to say that I've actually just literally ripped some of their slides off. So what I'm presenting now is very much my contribution to it is extremely minute, really, compared to all the other stuff. So I just wanted to just say that up front, and that includes, as I say, actually stealing bits of people's slides. Okay, so the first thing I want to say, I mean, disclaimer, I always start with a caveat. Anyone who's seen me talk before, I always start by disappointing you and then go up. I think that's my approach. So at the end of this talk, you are not going to run the model unless you already have access to it. It's very complicated. There's an awful lot of data. There's an awful lot of data science tools behind it, as I'll mention. If you're interested in running the model, we're obviously very interested to talk to you. So please either drop me a line, drop Rachel a line, drop the Strategy Unit inbox a line. We're very happy to talk to people about how it works and how we can help you with it. But it isn't something that we can point to an Excel sheet on a website and have you download and off you go. So I just wanted to say that up front. The other thing I want to say is there's a huge amount of kind of insights, work, derived values, parameterization. There's a colossal amount that sits behind everything I'm going to say today. The purpose of this talk is quite introductory, really. So I'm not. Something else I often say at the beginning of my talks is I'm hoping that each one of you will be bored for some of it and very interested by other bits. That usually means I'm hitting all the right things. So it's just going to be a hodgepodge of all the different elements. What I'm trying to do basically is just give you a bit of an overview so you understand what we've done and why we've done it, and also whet your appetite. So we've obviously got a lot to say on this subject. Others who know much more about it than me have got a lot to say about it, and that will be forthcoming. So look out for that. In all the places that you will find the Strategy Unit and the colleagues that I work with. So that with the caveats out of the way, I've pre-disappointed you. We'll move on. So as Rachel said in the intro, I'm kind of I'm sort of taking a bit of a why, what, how approach to this talk. So I will be talking about all of those different things. I kind of lent on the theme a bit too much. So I'm also going to talk about what did we learn when we were building it. And I'm also going to talk about who else might use the model in future. So again, a bit of everything, hopefully. And as I say, I imagine you'll be bored for some of it. Lean into it, go and get some tea. Or if you think these next few slides are going to be rubbish, get some tea and then come back for a good bit. Okay, so why did we do this? And I should say I was not here when they started doing it, so I'm definitely not claiming any credit for this bit because I was literally, I existed, but I was not in the Strategy Unit. I was doing something else. So the new hospital program, who are building lots of hospitals all over the country, as I'm sure many of you know, came to the Strategy Unit around 2020. I haven't done too much archaeology to derive the exact date, but it was around that time. And essentially what they wanted to do was predict acute demand in hospitals around the year 2041, because essentially, as you'd expect, basically the exam question was, how big does a hospital need to be? That is basically the question that they came to us with. I'm using we in the royal we here, of course. So there is existing work and knowledge in the unit. Particularly Stephen White and Jake Parsons have done a lot of work in this area. I'm sure many of you are familiar with those names. And there's obviously also stuff in the literature as well that was also was drawn on. So at the time, and I would say to this day, in fact, basically the problem that we see, or one of the problems that we see with this and related modeling enterprises, is there are lots of different models, lots of competing ways of doing things, lots of people who want to help you with it, lots of ways of doing it. But there's a lot of repetition and duplication in that work. But although there's a lot of repetition and duplication, actually people are not using a consistent set of standards. So although people are doing, they're sort of duplicating, they're not duplicating in a useful way, because actually the definitions and the numbers are different enough that actually you can't really compare the predictions very well. And I think that in particular, that's what the new hospital program we're interested in, is we are building loads of hospitals. We want a common approach basically to estimating demand, because we want to have a good knowledge across the piece of what we're doing. So yeah, there's a problem around kind of definitions and the way that people talk about things and define things. And of course, the other problem that we saw, and it's a problem that I've talked about in previous times. If any of you are familiar with me, you will know that I bang on about this quite a lot. Often a lot of the modeling work is proprietary. It's not shared. So it's not really possible to take some work that's been done and say, oh, we're going to improve this, we're going to add this, we're going to add that, because actually you can't really access what's gone on. And I think the other problem with that as well is that unless the methodology is shared, you can't really be sure that it's right. You can't really assure yourself that it's been done correctly. It's possibly a safe assumption to assume that the people who are doing it know what they're doing. But if you were to examine the methodology in detail, there may be particular differences you might have with that. And there isn't really any sort of ability for you to do that under the proprietary model. So we wanted to kind of buck that trend. Some of the other issues that we saw with models were they were very often given as point estimates. So the demand would often be given just as a fixed number. As we always say, if you give a fixed number prediction for any kind of forecast, you will definitely be wrong. The probability that you are exactly correct is basically zero. And it also doesn't give you any idea of kind of the range of assumptions, so the level of risk that you're taking. So sometimes, forecasts are made quite accurately, and doesn't really matter too much if you're wrong, because you're going to be wrong by, 10 beds or whatever, depending on what you're doing. And sometimes actually the forecast can be very uncertain. And failing to understand that actually can lead to a lot of problems with decision making, because you don't know how conservative to be in your approach, basically. So modeling and handling uncertainty, in our view, is important. There's often aggregation, high-level aggregation early on in the task, basically to reduce the computational demands of what you're doing. Particularly anything that uses Excel is going to have to make a lot of simplifying assumptions versus a row-level data set. And I will talk a little bit about computational issues and row-level data sets and so on as we go through. And also, often there are things that are not really considered, things that are important to what we think will happen in the future, and also just a general lack of a kind of shared view, partly because of the duplication and the different definitions. Often it's hard to come to a really kind of well-defined view that everybody's agreeing, these are parameters and this is what will happen. So those are all the problems that we saw. So our approach that we proposed some years back, as I said before, when I was not here, was that it should be a probabilistic model. Therefore, it should handle uncertainty. It should be transparent and open source, and it is indeed, I'm very happy to say, transparent and open source. I'm sure there are links in the slides to all the code. Well, not all the code, there's masses of code, but the main bits. If you want to see more of the code, either poke around on the GitHub or just ask me. We want it to be collaborative. I mean two things by that. Number one, we wanted to build something for the NHS that we felt people could build on. So if you go and see the code and you go, oh, this is rubbish, I can improve this in 10 minutes, please do. Take it away and improve it in 10 minutes and tell us what you did. We want it to be reproducible. So we want people to be able to come along and say, well, I know what your assumptions were. I want to be able to satisfy myself that this computation has been done correctly, which you absolutely can. I forgot to say the other meaning of collaborative that I meant. Sorry, the other meaning of collaborative that I meant was that we wanted to build a process basically where, for example, the ICB can make some sort of, because there are lots of things, as I'll talk about more in the parameters, there are lots of things in this model that are, we're all predicting the future, so it could be contentious. For example, the way that the region is going to handle frailty, there'll be lots of opinions about that. Some people will think that we have a very robust approach for frailty. Some people will think they don't, and so on and so on and so on. And so we wanted to kind of have a way of talking about things in a set of definitions and a way of working with the model that would allow people to kind of express what they think, backed by expert evidence, as I'll mention again later on, and come to a kind of consistent shared view that was, transparent and you could look at it and all that kind of thing. So it ticks all those boxes. And we have done that. So that's why we did what we did. So now I'm going to tell you what we did. I've told you in a very broad outline what we did, but let me just go into a little bit more detail. So essentially, it is a probabilistic model, and I'll explain a bit more about how the probabilistic element works in due course. And it takes into account lots of different things that are important when you're asking yourself a question about how many people will be in my hospital in the future. One of the big things there is demographic change. So demographic change means quite a few different things. So there will be more people in the future. That's a reasonable estimate by any yardstick. There may also be different ages of people in the future. It's likely, I think, in pretty much every region you could name that everybody will be older in the future. That the mix of ages will be different. And there's also something in there about what we call age-specific health status. And what that's about basically is saying a given individual, say a 60-year-old, is this healthy on average at the moment. In the future, how healthy will they be on average? Will they be less healthy than they are on average now, or will they be more healthy? I.e., will they require more or less hospital care? So that's all part of the demographic thing that we look at. And just to slightly reiterate, I'm not going to dig into any of these. So if you find yourself particularly interested in any of these, please ask questions at the end, or please contact us. But I'm not going to. This is really just skating across the surface of the whole piece. There's something called non-demographic change, which I have to say I think is one of the silliest names for something I can think of, because they've just put non in front of the first thing that they said. But nonetheless, that's what it's called. Non-demographic change is basically every change that's not demographic. Typical elements of that include things like different clinical standards. So they might be like, oh, we don't do that anymore, or we do that way more than we used to. And patient expectations is also another thing that's often thought to drive non-demographic change. So over the years, patients on the whole expect more healthcare. They expect more healthcare faster. That's just kind of how the world is. And that can change. Essentially, that can change the final variable, which is who's in your hospital. One of the really important elements of the model, which I'll talk a fair bit about later, but again, as I say, I'm just scratching the surface, is something we call categories of potentially mitigable activity. And that basically means, of the people who are in our hospital today, if we did things differently, would they not be in our hospital anymore? So, for example, we've got someone in our hospital, or I should say, for this example, we have a fraction of people in our hospital that we think are there because of smoking. If people didn't smoke as much, some of that fraction would be removed. How fewer people do we think will smoke in the future, and what fraction of those admissions do we think will affect that? And we have those for all kinds of things. The way that we manage frailty, the way that we manage falls, the way that we manage end of life, alcohol, all kinds of things. As I say, it's a separate talk, but that's that's a little introductory piece of it. And there are more things as well that we are looking to model. So although we're happy that the model functions and produces accurate, well, I say accurate, it's hard to be accurate about it. It's hard to make predictions, especially about the future. But adequate to within an industry standard predictions, we hope to add more things in due course, which I'm sure we'll talk about in the future. I already talked about this, didn't I? Look, I had some slides to help myself, and I very cleverly not used them because I remembered it all. Yes, and here's some. So there's perhaps some good examples that I didn't talk about with potentially mitigable activity. Length of stay reduction. There's been a big length of stay reduction in the last 20 years or so. Will that continue? And also things like converting inpatient stays to day procedures, converting outpatients to teleattenders, is all that kind of thing. These are all things that basically affect how many people will be in my hospital in the future. We have 92 of counting of those mitigators. I'm sure there will be more in the future. Okay, so what have we actually built? So we built the actual model. So if you follow that link in the slides, you will get to the GitHub repository that contains the model. We've also built some dashboards, which I will touch on briefly later on, that support people to set the parameters and actually run the model. And we've also built another dashboard that helps people to understand what's in the results. Conceptually, this is very complicated, as I'll touch on later. So we've done quite a lot of work on the sort of dashboard outputs type side to help people to kind of understand what the heck everything is, particularly when people are iterating. So it's quite common for people to kind of iterate, have conversations with various people in their region and so on. And being able to kind of look at a high level about what's coming back is a really helpful part of that iteration. We've written documentation. That sounds quite trivial, but I thought I'd mention it because actually it's very detailed. It's got a lot of very technical stuff about what we did. And it is part of our kind of mission to help other people stand on our shoulders and rip ideas off us and so on. So do have a look at the documentation if you're that way inclined. It's a pretty decent account of everything that we've done from a technical point of view. If there's something missing in there, I mean, you can file a GitHub issue if you're so inclined, or you can just drop us a line. As I mentioned, categories of potential mythical activity, that is a product. That is something that we have combined various brains and literature sources and so on to produce. And it is, we think, like a resource for people who are interested in these things. We've also produced a group of people who have successfully used the model in a business case. So I kind of wanted to mention this. It doesn't perhaps feel like an analytical task, but I think it is an analytical task in quite an interesting way. So we have already supported several NHP new hospital program schemes to use this model. And there's a lot of work in terms of helping people understand the implications of the parameters, helping people to kind of, land it and iterate. And, there's been a huge amount of work behind all that. It hasn't been done by my team. It's been done expertly in other teams in the strategy unit. And I think, as I mentioned earlier, this sort of collaborative, transparent approach where kind of, the region is given a voice and people are allowed to kind of say, talk about what they think will happen and so on, is something that we've tried to kind of incorporate as much as we can. And I think with a very great degree of success, which I think has been really important. I think sometimes people feel like these things have been sort of done to them. I've heard stories where a group of people will just come in and just say, right, there you go, that's what's going to happen in the future. And they look at it and think, well, that doesn't really fit with what we've. So we've tried to kind of buck that trend. And also we've sort of expanded the scope of what we're doing. So it was designed to basically to look at a hospital to say how big will this hospital be in the future. But we've actually also started to add in other kind of aggregations of healthcare data. So we have run the model at a national level for various purposes, which I'll very briefly touch on later on. And region's a bit more complicated than the national, because once you get into regional, you have to start thinking about, well, what is the region, who's in it, how is it defined, blah, blah, blah. But we are also doing that. So I think, for example, an ICB might be interested to know how many patients will be in all of their hospitals, that kind of thing. That could be useful. And other derived fields from the model. Okay, so the model itself. So this is a sort of slightly mathsy bit. As I say, basically, it's a probabilistic model. What that means in practice is it's what we call a Monte Carlo simulation. And that basically just means we do the same thing over and over again, but we vary the parameters slightly, and then we combine them all at the end. So there's probably about 100 parameters. If you include all the categories of potentially mythical activity, there's about 100 parameters. And each model run, basically, we sample from all those parameters. We look at the distribution of the parameter, all the parameters of distributions, as well as the output we sample from in those distributions. We do that for all of them. We calculate our model run, and we plot that point, and then we do it again. And we do that 256 times, and the spread of those values tells you about kind of the likely range, basically. So you've obviously got the median in the middle. Well, it's not the median, actually, it's the mean. We use the mean for various boring technical reasons. You've got the mean, which is the kind of what you call the point estimate, the kind of central tendency, and then you've got the distribution across those values. We do that for inpatients, we do that for outpatients, we do that for A&E, and we cut it in various ways as well. So conceptually, the model actually is a sort of row-level model. So the way that it works is we basically take a whole year of data. We take that from HES, and for each row of HES, we essentially mathematically say, do we think there'll be more of things like that in the future, or do we think there'll be fewer things like that in the future based on all of the parameters, the demographic change and this and that, all those different things. And then we do this randomly using a Poisson sampling. Basically, we either scale up that row if we think there's going to be more of them, or we scale down that row if we think there's going to be fewer of them. So it's like a sort of random process across the rows. So conceptually, that is a row level operation. We don't actually do it at row level. The reason why we don't do it at row level is because it would just melt the computer, because it's way too much data. I mean, you obviously could do that, but you'd probably spend an awful lot on cloud. So what we do instead is we aggregate it at various points. We kind of chop the data up in order that it kind of fits through the computer. But the reason why I'm saying that is, the nice thing about that is we're not stuck with those aggregations. So throughout this process, people have said to us, oh, well, what about this? What about this? What about this? And we say, oh, that's fine. And we just had that in as an aggregation layer. So any kind of particular way of chopping these, so you see, we can add that in. Okay, so that's the model. I just want to very quickly touch on the national elicitation exercise. This, again, is a whole separate talk. There's lots of whole separate talks, isn't there? I hope someone's keeping count of how many separate talks I've talked about. So basically, this is, we're predicting the future. Nobody knows what's going to happen in the future, obviously. But in order to look at these categories of potentially missing activity, we need to have some sort of notion of, for example, how fewer people will smoke in the future. And the way that we've done that is using a highly structured method. We've asked experts. There are lots of ways of doing this kind of thing. We've obviously used the one that we consider to be best. We did make some very whizzy data science tools to help people do that. So we kind of showed them what's happened in the past. You showed them the trend, and we've asked them what they think will in the future. And we kind of captured all the distributions, and we've kind of made this really nice interface. And I gather that's been really helpful. People have said that often when these exercises are done, they're kind of done with like bits of graph paper or bits of, and it's not, although that doesn't sound like much, it's not as, it's harder to kind of get through it. It's not as intuitive, and it's not as easy to look at the context and so on and so on. So I think those tools we built actually been really useful, and we've had loads of really great feedback about how much easier it makes. Because I think you don't want people faffing around with graph paper, do you? You want people thinking. So I think that's kind of the thing with data science sometimes, is it can just smooth the edges off a little bit. So that's nice, and we show those values basically. So we elicit all these values about what people think, what experts think will happen in the future, and we show them to people when they run the model. So we're not saying this will happen where you are, because every obviously regions are very different. But what we say is, to help you think about this, here's what some experts think about just the whole country. So you can sort of look at that and think, well, how different is my population in respect to that? I'm not going to say any more about that. This is all Professor Mohammed and team. They've done some really interesting, amazing work that I highly commend to you, but it feeds into the model. That's why I'm mentioning it. Okay, so I'm going to do something now that I never do, except I probably do it often and say I never do this, but you have to go to all of my talks to check. The cardinal rule, I believe, in these analytical things is you should never show a dashboard, because people roll their eyes and say another dashboard. I am going to show you a dashboard. You can all send snotty emails to Rachel about me if you like. I'm doing it not because I want to show you how clever we are that we built a dashboard, but just because it's a really quick way of just kind of giving you a summary of what's in the model. But I'm going to do this light touch, and I'm going to do it quickly because, as I say, I don't want to have you all rolling your eyes and thinking, well, we've got dashboards where I work, I didn't need to come to this. So this is what we built. And so I suppose the other thing to say is that I think this has also been really helpful in terms of helping people to interact with it. So, for example, there's more than one login for each hospital. So, it's not that frees it up from being like, oh, this person sits at a computer and puts the numbers in. We're trying to help people be like, well, like, have a go, like, other people look, see what you think, and just try to kind of like give people the tools and the information they need to do these things. So I'm just going to just quickly rattle off just some of the things just so you get a sense. So we have baseline adjustment. That's basically just because the data might be wrong. That's not very exciting and sexy, but nonetheless, we all know that NHS data can be wrong. So that's the is your data wrong bit. This is all about population growth, and we have ONS. We use ONS projections in the model. You can predict they offered lots of different types of ONS projections, so we offer people the ability to choose one of those. This is just a little bit about health status adjustment. This isn't configurable because it is based on a sort of analytical piece of work. There's a link on that page for people who are interested. This is all about expat repat. Basically, this is about what you know about how people will move around in your region. Obviously, that's very important. And as you can see, there's lots of useful information on here helping you to understand kind of what exists at the moment. There's non-demographic adjustment, which is the thing I was describing earlier on as having a stupid name. This, again, is based on a piece of analytical work. There is a bit of selection around here, but there's one that's sort of preferred. So we sort of, in this, we have a sort of way where we say, there are a couple of ways of thinking about this, but actually this is the one that we kind of think is the most likely, but do explore other scenarios for your own interests. And lastly, just very quickly, this is the where you look at categories of potentially missable activity. And as you can see, there's lots of information on this page, so it's really important to help people kind of understand what's going on. This down here is the national station exercise. You can see it's given us a range, quite a big range actually, this one. And the central estimate is this little yellow blob around the 75 mark. We have a trend, and this is alcohol-related emissions, this one. We have a trend here, and we also have a funnel plot. So the funnel plot is done against your peers, basically. These are so the red dot is you, and the black dots are your peers. And again, this is to help you think, well, how, like what are we like compared to other people? So is it likely? So for example, if it's quite high, you might think, well, it's quite high, so it might come down. Whereas if it's quite low already, you might think, well, I feel like we're already doing everything we can do here. Yes, that's. I'm not going to say, oh, and there's a run model button as well. I'm just going to just say that just for the sake of saying it. This is where the models run. So again, I think that we've slightly democratized it in the sense of it's not this big sheet that you take to these sort of, that you hand in at the bottom of a mountain and say, please run my model. We're giving people the ability to, have a look and iterate and all this kind of thing. So I think that's all kind of part of the approach. That's that. Way more you could say about that, but again, I won't take up too much time with it. And the thing I said I never do, I'm going to do it again. So that's 2 in 1 talk. Very quickly, just going to show you some of the stuff that actually comes out of the model. Again, not to bore you, I hope, but just to give you a sense of actually what I'm talking about. This is what we call the principal projection. So this is the mean, basically. This is the sort of the central estimate of what's happened. You can slice it by all kinds of ways, as you'd expect, inpatients, blah, 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 blah. I won't bore you with that. And it essentially shows what we think, what is going to be the level of demand in your hospital by sex and age. What is the change that represents? Oh, I've started in the wrong bit. Sorry. Yeah, this is a sort of high-level summary. This is about length of stay. This is a more detailed look. This is a waterfall chart. The maths of this is broken greater brains than mine. But we do, to the degree that we're able, show what we think are the effects of each of the parameters in the model. I should say up front, these are simulation-based estimates. These are not precise, but they are, we think, accurate enough to be useful, which is, I suppose, anything as good as a forecast model can ever be. And you can see it's basically got all the parameters in it. So you can see this is demographic adjustment here growing. This is non-demographic adjustment here growing. And there's some shrinking ones. There's some activity avoidance here. there's healthcare efficiencies here. This is just like a national run. This is the data on this is probably fairly meaningless. I don't even really know what this is, but I'm just showing it to you for interest. And just finally, these are 80% prediction intervals for those who like their numbers kind of with lots of sig figs. And these are, we also have a B-swarm plot where you can see each of the individual model runs. So I mentioned there are 256 model runs. Here they are laid out in all their glory. This red line here is the mean. This black line is where you started. And we also present an S-curve as well. It's the same information, but an S-curve is easier to read in terms of like from a centile point of view. So if you want, say, I don't know, the 30th centile, an S-curve is a heck of a lot easier to use than a B-swarm. B-swarm, you're going to be sitting there counting Bs. There's loads of much more detailed information. This is the sort of slightly iteration type view. There's loads of information available in Excel downloads down to pretty granular levels. And as I say, we can actually make it more granular where necessary and have. I could definitely talk all the way up to 12 o'clock, I'm realizing, Rachel, but that's a bad thing, isn't it? I should stop, 5 minutes before, 10 minutes before?
Yeah, so we've got quite a few questions. If you stop at 10 minutes before, then we can pick up some of them, and I'll promise people that the ones that we don't get to answer we'll do after the session.
Yes, and I'll say this as well. I'll pre-disappoint you on the questions. As I say, to be fair to me, lots of people worked on this. I'm not going to know a lot of the questions. So many of them I'm going to say, what a great question. I'll take that away. Anyway, I was going to kick off an analyst versus dashboards bonfire if the vibe seems right. And it does seem right, but however, there's no area of time. So let's have that fight another day. Some data science for those who are interested. Again, this is just going to be skimming over the surface. So there's a lot of data in this model. It's basically all of the hospital activity data for the entire country in a year. That is a lot of data. It sounds like a lot of data, and it is. So we used to use SQL. That took 4 days. It should take us 4 days to run the data pipelines, which is a problem if they break, and then you have to rerun them. So we use Databricks. I don't understand Databricks, but it's very fast and whizzy, and we all love it. In order to kind of make this kind of scalable and allow us to give people like have a run model button, go for it, we basically use Docker. So when you click that button, essentially what happens is a little Docker container kind of launches into the cloud with your parameters in it and does some stuff. I think it takes about 5 minutes, and then it comes back and it pops itself back into the outputs dashboard that I just showed you. There's loads of storage. We use Azure Blob Storage for that, as you might imagine. And the model is written in Python because Python is fast and there's an awful lot of computation. As I say, it takes 5 minutes. I feel like that's kind of pushing the limit of how long a model should take to run, really, 5 minutes. And we use R for the dashboards and for reporting because R makes beautiful things. So that's what we use. And we've written the documentation in Quarto. There's loads of documentation. We are quite proud of it. And we use Quarto for that. So do have a look at any and all of those GitHub repos for more information if you're interested. Now, I was going to talk about Agile a little bit, but I feel in 7 minutes, there are probably more important things for me to be talking about. So I'm just going to skip through. I'm going to sprint. So we used Agile. We used something called Scrum. We used to do 5-week sprints. Now we do 3-week sprints because it's more agile. We have sprint retros where we talk about what went wrong and what went right and how we can improve ourselves. It's really, really important and cool. I would definitely highly recommend it to anybody that's doing data science. Blah, blah, blah. I'm not going to talk about this in detail. I'm just going to very quickly mention Agile, actually, because I think Agile is something that has been a really important part of the way that we've delivered this. And I think it's a word I think a lot of people know, but I feel like the understanding of it is not always as deep as it needs to be outside of kind of very nerdy circles. So agility, I used to just think it's, customers can't make up their minds. They don't know what they want. That's why we're agile, because they ask for something and then they ask for something else. And also, we don't really know where we're going to go. It's hard to just design the whole project in your head. You have to kind of like see where you're going first. And that is what it is. That's not wrong. but it is so much more than that. And I've kind of been talking about that. So I just want to just very quickly land these points with you. So here's a couple of highlights from the Agile Manifesto. It's a thumping good. I mean, it's like a side of A4, but it will change your life. So I highly recommend it. I think in particular, the things I want to highlight on here, reflect on how you're doing. That's really, really important part of Agile. Regularly stop and think, what are we doing? Why are we doing like this? How can we do it better? Being technically good makes you more agile. So when agile isn't just for project managers, it's also for data scientists. So data scientists need to work in a way and write code in a way that doesn't paint yourself into a corner, that allows you to be flexible, because that's what delivers value for the customer. So we're delivering money. No, I wish we would. That'd be awesome. We're delivering products to people, and it's using taxpayers' money. And so for me, Agile really maximizes the value. So it's really, really, really important. It sounds just like a silly buzzword that people say because they can't make their minds up. But it's much more than that. And indeed, the last bullet point, I think, is a nice one of this. The art of maximizing the amount of work not done is essential. I think that's such an important point for any project management approach, not just Agile. There's so much wasted activity. I mean, I've never really worked outside the NHS, so I don't really know what it's like elsewhere. But I'm sure everybody is vibing with me saying there's so much stuff that we do that it's just a waste of time. And I think really thinking about that, planning it and looking at things critically and thinking what's the need here is really, really important. So I'm going to shut up about Agile now. Again, I'm going to mention this at high speed as well. We've also started looking at products. So we've started thinking about things in terms of how our users are. I think that's another thing in analytics as well. Sometimes we kind of make what we want, like I've done this. You go, well, this is what Chris Beeley wants. And, they don't want what Chris Beeley wants. They want what they want. It's early days for this, but we are really trying hard to think about, like, who's at the end of this? Like, what are they doing? And in particular, there are loads of people. Like, it's not just one person. This is, as I mentioned, we've met all of this with documentation. There's all these categories. There's all these different things. And it's not only about who might use them today, but it's about who might use them tomorrow, or even about who might use this code for something else in the future. There's such a, and again, this is all about maximizing taxpayer value. That's what it's all about, is what can we do that makes everyone do their actual, in the real world, how to do your actual job, rather than look at a fancy graph. I'm landing very accurately, which I'm happy about. So what are we doing in the future? So we are still working on this, running the model at national and regional level. It is very complicated and difficult for lots of reasons that I don't have time to talk about. Much to do with computation and definition. So we are continuing to push on that. Again, in terms of thinking about users, I think it could really help us to help more people. We kind of want to have a bring your own data approach. So what I said at the beginning, you're not going to run the model at the end of this talk. So I pre-disappointed you there. The code is open. If you have access to his data and all the kit that we have access to, you absolutely can run it at the end of this talk. And I hope you do. That doesn't describe many people in the world. So what I'd ultimately like to get to a point where we are better able to kind of bring this model to where people are. So like, this is my model, that's your data, you keep hold of your data, you have my model, pop it in, out it comes. That is phenomenally complicated and difficult, but it's something that's on our radar. The FTP is definitely a very obvious candidate there, because that's, as far as I understand it, the point of FTP is it allows you to kind of use your data with an analytical thing. And also it makes it simpler for information governance and stuff. I kind of want to just give the model to people and say, just keep your data. I don't even want to look at it. You run it on your data. That's a lot easier. I put FTP question mark because I actually don't really understand FTP, or not fully. But it's, I think, promising. We want to understand more about these categories of potentially mutable activity. That's a real part of this. It's not just about who's going to be in my hospital. It's going to be about, like, who isn't in my hospital? Where are they? Who are they? Like, are they okay? All that kind of thing. There's way more to be done and said about that. Not by me, but by others. And along similar lines, also just thinking about, we've done all this work on acute hospital activity. Like, how do we contextualize that into, that's part of a system, isn't it? How else can we understand the links into the hospital, links out of the hospital? How can we sort of build this into a more system-wide view of, yes, okay, that's your hospital, but actually what's going on elsewhere? And there's clearly a colossal amount of work and understanding and modeling and so on to be done there. Right, that's it. So I sincerely hope you were bored in some places and enthralled or others. That's all I want to say. And as I say, there'll be much more to say in the future. I hope that was of interest.
You got lots of applause, Chris. I think you hit the spot. Got the right balance. So thanks very much for that. That's a really helpful overview, introduction to what is a very complex model, which has taken quite a long time to get to where we're at today. And there's a journey ahead as well, which is why we're kind of sharing it, I think, more widely with people now. Let's get to some of these questions, Chris, because there's a few you will definitely know the answers to.
Thank God.
Share my screen. Obviously, I've posed a couple of really tricky ones just to, no, I haven't really. I would not do that to you. Let's see if I can just share the screen with the questions on it. And so I do this in two ways. Sometimes I can confuse guests by doing this with my mouse, and then they go, well, we won't do. So if you just pick, I can see 6 questions on my screen. If you just want to go from top left and then just follow them down, and we'll see how far we get.
Yes, I think a really good way, I'm happy to do that, and I will do that to the best of my knowledge. I feel like a really good way of doing this as well. I think we should probably take all of these questions away, actually, because I bet
okay.
But let's see. I'm just saying that up front.
Sure.
Right. Can you tell us about plans that are DES to take demand output and convert to required capacity? The answer to that question is no, I can't tell you about that. We will take that question away.
Okay.
It is a good question and it's important. Have you updated the demographic change of the 2022 estimates? The answer to that question is yes. Does the model account for planned housing growth that isn't in the ONS projections? The answer to that question is no, but it could. That's not difficult. What is difficult is coming up with an estimate for those planned housing growth that everyone agrees with. Once you've done that, and that's not we don't have population growth experts here, but if you want to run the model and you have access to decent population projections, that is, I'm told by my brilliant data science team, quite simple. Right. One of the principles could be used by non-NHS people, and we're talking about reducing or avoiding care. Yeah, so as I say, at the moment, it is a big load of code that runs on HES data. Anybody with the code, which can be downloaded from GitHub, and HES data can do exactly what we did. Not pretending it's simple, because it's really not. But you could. So really, that question's really all about access to data. I want to, as I say, one of my things with this is I want to help more people use the model in their own way using different data. I'm sure all the analytical people in the audience will appreciate it when I say doing that, generalizing something from a specific data set to something that's a bit more general is horribly, horribly complicated. So there's no easy solution to that. If you've got a specific thing that you want to ask about that, please drop me an email and I'll be very happy to kind of look at it and think about what that might mean.
I was just thinking sort of in relation to that, I suppose so much of this right-sizing hospitals and so on, so much of that is also about, like you mentioned, who's going to be there, who's not going to be there, where they're going to be. Well, the where are they going to be? That's the non-NHS, potentially the non-NHS bit. Some will be and some won't be. So some will be social care. There'll be sort of lots of other sort of data or sort of prevention activities and so on. So I think it's sort of running the model with the data is one thing, and it's just having that recognition about the relationship. And of course, we know from our sort of experience so far that all of these stakeholders, all of these non-NHS stakeholders have been involved with those inputs. So not the dashboard that you called it, and Matt corrected you. He said it's a parameter inputs tool. So that parameter inputs tool has been, so far, that's been had stakeholders from across the board, NHS and beyond. So it's just, I think it's just to make it clear that it's not it isn't restricted in that sense. The contributions to it to make it sort of holistic and reflecting a whole system are there. They're kind of built in. But yeah, okay, take points of this one here. So for mitigatable activity, and we love that word. Hands up who absolutely loves that word. Are we able to scenario generate and change the starting points?
If you mean the starting point in terms of year, then no, that's not simple at the moment. But the model, I mean, the model does allow, there's nothing conceptually in the model that would stop you from doing that. I'm assuming that's what that means. We can certainly do scenarios. That's kind of, that's one of the kind of things that we want help people do. Changing the starting year, yeah, that's not something that we really currently support, partly because it's not really something that's needed at the moment. But conceptually, there's no reason why you couldn't generate something that did that. I hope that's a helpful answer to that question.
Okay. Let's just do a couple more. Can we have the link? Yes, you can. So that's an easy one, Chris. I've done that one for you, so I'm not gonna
Yes,
give you the easy ones.
Please have a look at it. It's very interesting.
Absolutely, yeah. And you've also done. There's also a blog and there's some various other things on the strategy unit website about this as well, just to get a bit more information. Here we go. Another one for you, Chris. Hi, Chris. Currency.
Yes. So the model outputs admissions and bed days. It does not output physical space. It does not output it doesn't output physical space and cubicles, but that is something that's on the radar. I didn't actually talk about that today, which I probably should have done, actually thinking about it. Yes, we want to come up with a sort of systematic way of converting demand into things like physical space, but we do not currently do that.
Yeah, I think there's some recognition that there's a lot of variation in where that's done across, in different hospitals across the country. There's an appetite to have that more systematic and a more robust way so that people can know how to do some of these things. And yes, we are working on that. I know people are working on that. So here's one. So does the model have the flexibility for potential future changes in the structure of regional service delivery, parameter changes associated with regional boundary changes, for example?
Yeah, so I think the answer to that is if you can express those in terms of expat repat, if that's possible, then yes, definitely. If there is some mathematical way of doing that. If it's something other than that, again, yes, conceptually, I'm sure the model could do that, but you would have to you'd have to go into the back end data basically and futz around with it essentially, because you would be putting different things in different boxes.
I think it might depend on so my experience might depend on what the actual service is. Sometimes if it's specific enough that it's quite easy to accommodate those planned changes and expat repat sort of activity. In others, it's more complicated. It's like with everything. There's no set answer. But I think there is some certainly flexibility to be able to do this, and certainly it's really important to accommodate this as well, because these things do change. And if you're planning a new hospital, for example, you need to be building in what you know to be happening in terms of changes in service provision and where it's going to be and so on. Should we do two more? Okay, here's one. Let's do this one. Why was the Monte Carlo simulation used, and were other models tested?
Yeah, so other models weren't tested. It's a good question, this. They weren't tested. The problem with this whole region, and I'm not really the person to answer this question, so forgive me, is it's not like a sort of standard machine learning task where you ask it to classify a load of dogs and you calculate how accurate it is in percentages, because we're talking about 15 years. So you'd have to wait 15 years to get those predictions. Now, you could obviously go back in time. So you could say, well, okay, you can't wait 15 years, but why don't we go back in time 15 years and run the model from there? I think the problem with that is that we don't really believe that the model parameters pertain 15 years ago in particular. So although we haven't tested it in that sense of kind of area under the curve and all that malarkey, this is a sort of an approach that's recommended by the literature. I mean, it's just a logical approach, basically. All the model does, as Tom on my team always says, it's quite a dumb model in a way. All it does is just take what you think will happen, what ONS think will happen, what you think will happen. It just takes a load of predictions about what you think will happen, and then just does a Monte Carlo simulation based on them. So if you believe the things that you think are going to happen, then the model will work, because there's no fancy stats or anything. It is basically just computing what you think will happen. And if you don't believe the things that you think are going to happen, then the model will not work, because it's based on something that you do not think is going to happen. And that is kind of a stupid answer, I realise. But that is all we're doing. There isn't really any sort of cleverness underneath the hood that does anything else other than just take your own views about the future and present them to you back in a sort of mathematically derived fashion.
Yeah, so it's your views, your colleagues, your stakeholders' views. It's sort of it's a compilation to get the most accurate position or understanding of your future, and that's in relation to what strategies you got in place, what strategies you got planned, and that kind of thing. So it's very specific to what's happening in particular systems. They've got lots of other questions, and I've realised that how much more there is to talk about, Chris. That we need one a month of this, and I think we're going to be putting some other talks on, just so we can go through some of these in a bit more detail. But we have hit 12. It has gone well. We've got loads more questions. So what I will promise to do, I will share those questions with you. There's some really good questions, which will help us actually as well to make sure that people have a good understanding of the model and how it can be used. And then I'll put some of those responses on the website with the questions alongside the presentation, with those links to the model, the code and so on that you've mentioned, and also the recording of this session as well. So smile nicely, Chris, because this will be a recording. This will be the final take.
My face is stuck like this, I'm afraid, Rachel.
Sorry. Oh, really? Oh dear. Nice.
You didn't bring me on for my face, I'm sure.
Well, anyway, so we have just gone over 12. We had lots of people who probably got tummies now, so they're probably want to run away. Thank you, Chris, ever so much for going through that with us. I know it's very complicated, and there's a lot of people and a lot of work that has gone into it. It's been a really useful overview, introduction to the model that we all get pretty proud of. I think if people have got their hand up, I'm so sorry we haven't got time to take questions, but hopefully you're just saying well done. And thank you everyone for coming. So it's been great to have you in the room, and I don't have time to tell you about the things coming up, but I'll do that via an email, do not worry. And I look forward to seeing everybody again in a couple of weeks, when it's going to be Mark Farr. No less. Mark Farr is going to be here, and he's going to be talking about I do not know what. He hasn't told me. He will tell me, no doubt, in due course. But it'll be really good to come and see Mark in 2 weeks' time. Thank you, everyone. See you in 2 weeks.
Thanks,
okay,
all.
goodbye. Bye.
Thank you. Bye.